Next, we need to talk about the sum, difference, product, and quotient of functions. So as long as I know I have a function, right, functions pass the vertical line test, each x has exactly one y value, I can find the sum of those functions, the difference of those functions, the product of those functions, or the quotients of those functions, just by going ahead and adding them, subtracting them, multiplying them, or dividing them. So let's go ahead and find the following functions and state their domains. So the first thing I want to take is the difference between f and g. So let's let f of x be 1 over x plus 2, and g of x is x over x minus 1. So I want to find f minus g of x. So I'm going to take 1 over x plus 2 minus x over x minus 1. Now, in order to subtract these two functions, they need to have the same common denominator. So we're going to find that the lowest common denominator between these two fractions is going to be x plus 2 times x minus 1. So for my function on the left, I'm going to multiply it by x minus 1 over x minus 1, and let's leave this factored, shall we? Then on the right, I'm going to multiply by x plus 2 over x plus 2. That gives me x minus 1 over x minus 1 times x plus 2 minus x times x plus 2 over x minus 1 times x plus 2. So we can go ahead and simplify this to be, I've got x minus 1 minus, let's go ahead and FOIL this out. X squared plus 2x over x plus 1, x minus 1, x minus 1, x plus 2. That means I have x minus 1 minus x squared minus 2x over x minus 1, x plus 2. That gives me a negative x squared minus x minus 1. I'm going to pull out a factor of negative 1 in order to determine if I can factor my numerator. So I get f minus g of x equals negative x squared plus 1, x plus 1. So are there any factors of 1 that add to 1? No, they're not. So my numerator is fully factored, and I have a denominator of x minus 1 times x minus 2. So next I need to figure out my domain. And we figure out what variable values need to be left out of our domain by setting our domain equal to 0. So I have x minus 1 equals 0 and x plus 2 equals 0 using the zero factor property. I have x equals negative 2 and x equals 1. So my domain is going to be all x values such that x doesn't equal negative 2 or 1. So that's how we found f minus g of x. Now let's take f of g of x. F times g of x. We're trying to find the product. So in order to find fg of x, I'm going to go ahead and take 1 over x plus 2 times x over x minus 1. When I multiply fractions, I multiply their numerators and I multiply their denominators. And I'm going to leave this in factored form because that helps me more easily see what my domain is, right? I have to set my domain equal to 0. I have to set my denominator equal to 0 in order to find our domain. And just like last time, we found that x such that x doesn't equal negative 2 or 1. So that's going to be the same. Last but not least, let's find the quotient. That means we're going to divide these two functions. So if I'm dividing two functions, I keep the first fraction the same. I change from division to multiplication, and I flip the second fraction. So I keep first fraction the same, I change from division to multiplication, and I flip my second fraction. So I flipped this guy. This means I have x minus 1 over x times x plus 2 is the quotient of these two functions. In order to find my new domain, I set my new denominator equal to 0. I get x equals 0 and x plus 2 equals 0. So I get x equals 0 or x equals negative 2. Both of those would make my denominator 0. So my domain is all x values as long as x doesn't equal negative 2 or 0.